Hello, this is your lucky sir. Chemical kinetics first order reactions, class 12. Very, very important one. What do you mean by first order reactions? First order reactions are those reactions in which rate is equal to K into concentration to the power of 1. If you write the reaction as R gives rise to P, reactants convert into products. R is reactant, P is product. Like that, if you take, then rate is equals to K into R to the power 1. When you write like this, that means if the rate is depending on the concentration of the reactant to the power of 1, then that is first order reaction. All radioactive reactions are first order reactions. Radioactive decay reactions or disintegration reactions. And one very, very important, very popular reaction known to you is radium reaction. Radium 88 226 will turn into radon 86 222 plus helium 24. I think you remember this reaction because the speciality of this reaction is you are getting two noble gases. Radon is a noble gas and helium is a noble gas. You need to remember, right? So this is a first order reaction. So if you want to write rate is equal to K into concentration of radium to the power 1. Or you can go for acidic hydrolysis of ester. Correct? Ester hydrolysis in acid medium. Acidic hydrolysis of sucrose, all these are going to be first order reactions. And hydrogen peroxide decomposition, N2O5 decomposition, okay, N2O5 decomposition to form N2O4, or you say 2NO2 plus O2. It's going to be again first order reaction. NH4NO2 on heating gives N2 plus 2H2O. N2O gives rise to N2 plus O2. All these are going to be first order reactions. First order reactions are very common. Most of the reactions are following first order kinetics only. So we need a equation for the first order reaction, that is called integrated rate equation. For that purpose, now we are going to discuss. Let's take R is equal to P. This is your reaction. Now how we write about this? The rate minus dr by dt is equal to K into concentration of R to the power of 1. 1, there is no need to write 1, right? R to the power 1. Now this I am writing like this: dr by R is equal to minus kT, kdt, sorry. On integration of this, okay, now you know the integration rules you are going to learn in class 12, I think. In mathematics, you will be getting integration. And integration of this, you will be getting there this as ln R is equal to minus kT plus I. This is going to be the expression. On integration, ln R is equal to minus kT plus I. Now, I want to go for T is equal to 0. Then concentration of R will become R naught. R naught is the initial concentration. When R is equal to, when T is equal to 0, that means time is 0, then the reaction is yet to start. इसका मतलब होता है अभी reaction का start ही नहीं हुआ तो concentration will be initial concentration. And we are saying initial concentration is R naught. Fine? Good job. So now that you substitute in this expression so that it becomes ln R naught is equal to minus k, time is 0, plus I. It means I is equal to ln R naught. Right? Now substitute this I value, integration constant I value, in this expression again. So it becomes ln R is equal to minus kT plus ln R naught. Right? Very, very, very simple derivation type thing we are doing. Now kT is equal to what we can write? KT is coming this side, this will be going that side. Ln R naught minus ln R. When you are subtracting something in logarithms, we can write like this: ln R naught by R. Correct? Or natural logarithm, if you want to convert that into log, base 10, then that will be r naught by r, and this you can say k is equal to 2.303 by t log of r naught by r. Fine, this is your expression. You want this expression. K is equal to 2.303 by t log r naught by r. In general, we write K is equal to 2.303 by t log a by a minus x. A is initial concentration, a minus x is concentration at t time. A minus x is concentration at t time. Meaning is same, but generally we express like this. Then half-life. Half-life is t half, correct? T half means t is equal to t half. Half time is gone. Then concentration will become will become r naught by 2. Initial concentration will become half. And when you substitute these things in the above equation, the equation will turn like k is equal to 2.303 by t half log initial concentration is r naught by r is equal to r naught by 2. R naught cancel. R naught by 2 means the 2 will be coming upside. This is cancelled. 2 will be coming upside. That is nothing but log 2. So 2.303 by t half log 2. So k will become k is equal to 2.303 into log 2 value is 0. We'll write once, no problem. 0.3010 by t half. So k is equal to, or you said t half is equal to, when you are multiplying those two, 0.693 by k. So t half is equal to 0.693 by k. Is there any a term? Is there any initial concentration term? R naught term, initial concentration term is not there. That means t half is proportional to a to the power 0 for first order. When we discuss zero order, we say t half is proportional to a. This is a to the power 0. First order a to the power 0. Very interesting. Very interesting point. T half. And T half graph, if you want to take T half versus A, the graph line should be like this. Correct? Done. One more graph we'll take here. That is ln r versus time. The graph will be with a negative slope with an intercept of ln r naught, and slope is, negative slope is there, that is minus k. Or from this expression, again we can take one more graph. From this expression you can take one more graph, that is log r naught by r, log r naught by r versus time if you take. So time when you take, you will be getting a slope like this, k by 2.303, positive slope will be there. Log r naught by r versus time is increasing graph. Slope is positive, k by 2.303 is the slope. And the above graph, this is very similar to zero graph, zero order. Zero order, we are taking r versus time, we are ln r versus time. That is the only difference. So this is about chemical kinetics, first order reactions. One more line I will convey and I will complete this. That is T half is to, T half means T 50%, 75%, 87.5% if you are taking like this, that is 1:2:3. Fine, quite interesting. And T 90%, 99%, 99.9%, sorry, 99%, 99.9%. If you take like this also, 1:2:3. And T 50% will be 10 times, T 99.9% is, T 99.9% will be 50% of T 50 into 10 approximately. These kind of things if you remember, that will be a wonderful job, right? So this is your Lucky sir signing off.